Chapter 27, Theory Video 3. Rectification is what we are going to talk about. We know that most of the electrical appliances work with alternating current, but there are some that can work with both DC or AC. However, some electrical components or equipment uh, they require DC. So then we will have to convert the alternating mains current into direct voltage. We have to convert the alternating mains voltage into direct voltage by a process called rectification. Right? So here what happens is there is a AC supply which goes through a diode and a load resistor and provides a voltage out. So in the voltage out, what happens is we remove here as shown here, the negative voltage has been removed. So you know what a diode is. Diode allows current to pass through only in one direction. So in here what happens is the diode eliminates current in one particular direction. Then the diode will conduct only during the positive cycles of the voltage. So there is a there is a current in the load resistor only during positive cycles. So then so this is actually something like chopping off the negative cycle. This type of rectification is known as half wave rectification. For one half of the time the voltage is zero. So that means when we use half wave rectifiers, the power available is reduced because one half of the power is not going to be available. Then there is another process called the bridge rectifier. So to now retain the power, we use a bridge rectifier circuit. So there are four diodes connected across this input alternating voltage. Then the output voltage V out is taken across the load resistor R. So then what happens is the output voltage across the load resistor would be fully rectified. So there is a we will look at the diagram first and then we will come back to this. So there is an AC supply and the current is supplied in this direction as shown here, right? And then the V is voltage out is going to be fully rectified in that manner. So let's see how it is done. When the positive cycle of the input is there, when the positive cycle of the input voltage, A is positive and B is negative. A is positive and B is negative. So as you can see here, A is positive and negative, B is, we are looking at this, A is positive and B is negative. Then the diodes 2 and 3 conduct because they are both in forward direction. Then diodes 1 and 4 are in reverse bias, therefore they don't conduct. So the current in the load resistor R is going to be downwards. And then the negative cycle, we will come to the details there when looking at the diagram. In the negative cycle, B is positive, A is negative. So as a result, diodes 4 and 1 will conduct because they are in forward bias. Diodes 2 and 3 are in reverse bias, therefore they don't conduct. Then the current in the load resistor will be downwards again, right? So then this is what happens. So in this particular situation, this is what happens. So as you can see, along the load resistor, you are going to have a current in the same direction. Right? In both the positive and negative cycles, current in the load resistor is always the same. So that means the top end of resistor R is going to be positive. So using light emitting diodes, we can create a bridge rectifier. So now we can actually a light emitting diode will light up when a current flows through it. If we connect this bridge to a slow AC supply, we can actually we can see how the diodes conduct during the rectification. That means there would be a a sequence of lights being the current being lit up. So that is how you must have seen in light emitting diodes they use different variations of uh, switching on. So that is using slow currents here. Write down a note. Rectification. Using diodes, AC current can be converted to DC so that some electrical appliances can be worked. This process is known as rectification, and please draw this diagram 27.11. Then underneath that, write in the above situation, the negative voltage has been chopped off, resulting in a reduction of the power that is available. To prevent such a half wave rectification resulting in reduction of power, a bridge rectifier is used. This consists of 4 diodes connected across the input alternating voltage as shown below, and then please draw figure 27.12. This both of these, the graph as well as the circuit. Underneath that, write during the positive cycle in the input voltage A is positive and B is negative. Diodes 2 and 3 conduct because it's in forward bias. The other two would not conduct. The current in the load resistor R is downwards. And then draw 27.13A. This one, A part. Then leave a line and write. The reverse happens during the negative cycle and still produce a current downwards through load resistor. Please draw 27.13. As a result, the power will be conserved. Please do question number 11 before moving on to the smoothing process. Now, so now we have a bumpy DC because it is not, there are some fluctuations here. As you can see, there are fluctuations. So to make it more steady, we have to follow a process called smoothing, and we use a smoothing capacitor to get this done. When we say that the capacitor has a capacitance of C, it is connected in parallel with the load resistor of resistance R. So what happens is, capacitor charges up and will maintain that voltage at a high level. So when the rectified voltage is dropping, it will discharge slowly. But because the voltage is going to rise again, the capacitor will charge up again. So this is going to have a ripple effect. So as a result, we have this. So at this point, capacitor is charging, and then from here to here it is discharging. So it is smoother than having like this. I hope it makes sense. So we can actually control this ripple by choosing the capacitance and the resistance carefully. You will know that a capacitor, if it has a high capacitance, it will discharge more slowly, and as a result will give a small ripple. If the resistance is increased, then it will also lead to a slower discharge of the capacitor. So we have discussed discharge of capacitors in capacitance. So again, we can increase the time constant of both C and R of the capacitor and resistor circuit. So as a general principle, we say that CR is going to be should be very much higher than the time interval between the adjacent peaks of the output signal. So that means you need the capacitor to be discharging between the gaps also. So in the worked example, when you go through the worked example, you will understand how that is possible. Write down a note. Smoothing. The DC current that is produced by rectification is not quite smooth. To smoothen this, we use a smoothing capacitor. This capacitor with capacitance capital C is connected in parallel with the load resistor of resistance R. When capacitor charges, it maintains a high voltage, but when the rectified voltage starts to drop, it will discharge. Maintaining that voltage in the circuit. However, When the voltage rises again, the capacitor will also charge, and this cycle results in a small ripple. Please draw both of these two. 27.14. This ripple can be, leave a line in that, this ripple can be controlled by using a capacitor of high capacitance, that is within brackets, right, a capacitor that takes a long time to discharge, and a larger resistor which would increase the time it takes for the capacitor to discharge. Right, now let's look at this worked example 2. So here, there is an output voltage from a half wave rectifier. Then the load resistor has a resistance of 1.2 kilo ohms. So a student he wishes to smooth the output voltage by placing a capacitor across the load resistor. So with the help of a calculation, suggest a 10 picofarad capacitor or a 500 microfarad capacitor would be suitable for this task. So first of all, what you need to do is we have to find out the time constant for 10 picofarad capacitor. Time constant is equal to CR. C is 10 to the power 10 into 10 to the power minus 9 multiplied by R is 1.2 into 10 to the power 3. So those are the details they have given. So we get 1.2 into 10 to the power minus 5 seconds, 0.012 milliseconds. Then we have to compare the time constant with the time interval between the adjacent peaks of the output signal. Time constant is 0.012 milliseconds. It is very small compared with the 40 millisecond between the adjacent peaks of the output. So if this is used, we know that the capacitor is going to be discharged very quickly. As a result, there won't be any smoothing. So 10 picofarad capacitor is not used. So as a result, we know that for smoothing to happen, we need the capacitor, the CR should be higher than the time interval. So time constant here, when we find it, it becomes 600 milliseconds. It is larger than 40 milliseconds. So as a result, we can figure out, we can understand that it is what we need is the 500 microfarad capacitor. I hope that makes sense. If you understand that, do question number 12, 13, 14. If you don't, please ask me questions. After you have done it all, please do the endo chapter. So what we have learned are the equations that we have learned are in a sinusoidal alternating current, it can be represented by I equals IO sine omega t, where IO is the peak value of the current. Then root mean square of an alternating current is the steady current that delivers the same average power as the AC to a resistive load for the sinusoidal AC. So the direct current, the same amount of power that is delivered by the DC is what we compare to the AC power. Then IRMS equals IO upon root 2. Then the voltage mean square, root mean square voltage is the relationship when you get VO upon root 2. Then we learned earlier, in earlier video, we learned that power can be equated to these values if we take the Vrms and Irms RMS values to AC current. So it is taking the average, like then P equals Vi, P equals I squared R, and P equals V squared upon R we can use for all of these. Then a single diode, if we use a single diode, that is a process known as half wave rectification of alternating current. If you use four diodes, it would be a bridge rectifier, and you have a full wave rectification of an alternating current, which does not reduce the power. Then if you use a capacitor in parallel with a resistive load, it will smooth, but you have to remember that the CR, time constant CR of the capacitor resistor network should be higher than the time interval between the waves. So that is something that you need to understand. If you have understood, please continue to do the questions. If you don't, ask me questions.